on the soup can, if you will. The it actually ends up being a rectangle. I don't know how much you've seen that, but where the top is the circumference, and then it's the height. So that's how the formula for the lateral area is made. It's 2 pi r times h. Because, well, it's a rectangle. So you get 2 times pi times 7 times 10, and that's 140 pi.
Okay, yeah, that makes sense.
All right. The total area or the surface area is always the lateral area plus the base or bases. In this case, there's 2 of them. So you have to know that, like, it's not just one base, it's that there's 2 circles this time. So it's 140 pi plus 2 times pi r squared. Radius is 7. So we got 2 times pi times 7 squared. And that's 98 pi plus 98 pi.
That's 238 pi, yeah?
Yeah.
Okay.
No units because we don't have any units squared if you had units.
Okay.
Okay, any thoughts on that or any questions?
So for the lateral area of a cylinder with like the soup can like label, how can you like just go over like where like that formula like derives from again?
Yeah, absolutely. So one of the things like that I always thought they would do in the classroom is they'd have you take a sheet of paper, your standard 8.5 by 11 sheet of paper, and then you rotate it sideways and then fold it up so that it has that cylinder shape to it. You know what I'm talking about?
Yeah. Yes.
And that's where it comes from. That's where you're like, oh, the top is the circumference. Okay, so this label has a top part, which is the circumference of the circle. Sometimes you even see that they'll put it like this, and that's where it's coming from.
Okay.
Is that C unwinds into this, and then the height is the height. It would actually be a really good exercise in the classroom to have the objects out, like looking at them. I don't know that they do that, but seeing the 3-dimensional shapes is a lot easier when you can touch them rather than on, computer screen.
Yeah. Okay. Cool. Thank you.
All right. Next question here is for, let's see, I didn't even get that stepped in. Let's see here. I got a snip. All right. So the total area of each solid, so it's the surface area, and they're giving you these lines, but you're supposed to not include like the base of the cone because it overlaps with the base of the cylinder, or the top of the cylinder. It's like imagine this thing just had like you're just painting the outside of it, including the bottom. That
Okay.
would be but you don't want to like double count either, because these are neither of these are included. Right. So like it's like a little bit like, well, what you almost want to say, okay, from the cone, what do you have? Well, you just have the pi RL, just the lateral area of the cone. Just the part, if you ever taken one of those paper cups at a water dispenser and it's a cone, this lateral area has this formula.
Okay.
From the cylinder, you get the pi r 2 pi r h, but you also get one of the bases. So you have to sort of decide like what is it that you're given.
So I'm only finding the lateral area of the cone, but I'm finding the total area of the cylinder.
That's right. Well, no. The cylinder is just the bottom, not the top. Like normally
So
you
we're
would add,
not counting, we're not counting the inside.
that's right.
Okay,
Because you couldn't see it. They're just showing you these are called construction lines. They're trying to show you that it's there, but yeah, you
so like normally if I was just finding the total area of the cylinder, then it would be 2 pi RH plus 2 pi R squared.
exactly. Yeah.
Okay,
Right. So we got pi 2 times 5 plus, you're always adding these, 2 pi 2 5 plus pi 2 squared.
so that should be 34 pi.
So yeah, sorry, I was looking at something else. 10 pi plus 20 pi plus 4 pi is 34 pi. Yes, you got it. All right.
Okay, cool.
Any thoughts on that?
Well, that makes sense.
Okay. All right, this is a hemisphere, half sphere. The total area includes the area of the circular base. So your hemisphere surface area formula we've not really talked about, but it is 4 pi r squared. But this is not a sphere. This is half a sphere, which means you have to cut this in half. But then you also have to add the base, which is another pi r squared.
Okay, so the surface area of a whole sphere is 4 pi R squared.
Right. But since it's a hemisphere, it's only half.
Okay,
And then you have to add on the circular base. So it ends up being 2 pi r squared plus pi r squared. You can actually combine these together because they're both the same, pi r squared. So it's actually 3 pi r squared. And then the radius is 6. So you just square it like that.
okay.
So it looks like it ends up being like 78 pi.
Yes.
Very good. All right, so that takes care of number 4. On to 7. More of the same. Okay. All right, so 7 is total area of each solid. So this time they're not giving you all the dimensions that you really need. You have to calculate them. They're helping you out by showing you that this is a triangle, a right triangle, particular.
Mm-hmm.
So you have to find the other leg of the triangle.
Which would be 5.
Yes, good. I'm glad you just knew that. That's good. It's a Pythagorean triple. The book uses them all over the place. So the total area of this is the lateral area, pi RL, plus the base pi r squared. So go ahead and calculate that for us, please.
Okay. 90 pi.
Let's actually go to C next. Hopefully that's not too upsetting to go out of order.
No, yeah, that's okay.
And I sometimes do that. I think it's good for learning to do one like it. So again, you've got enough here to find the slant height. There. You first need to calculate that, and then same thing for the total area. Use the same formula and see what you come up with.
Okay. I got 480 pi.
So pi r is you get 15 for, sorry, 17 for L,
Yes.
plus pi 15 squared, 225 pi, plus whatever that is, 225 plus another 30, so 255 pi. And then, yeah, you said like 480 pi.
Yes.
All right, you're doing great. So let's see, next problem here looks like it is a cylinder. And again, you have to find the missing dimensions, we'll say. In this case, you first find the diameter and then use the diameter to find the radius. Do you have the formulas for this?
For which, just like for the
Yeah,
area of the cylinder, or
yes. Yeah, for the cylinder. Do you need me to remind you of those for surface area and total area?
that's 2 pi r height plus pi r squared, right?
Two of them.
Yeah, 2 pi r squared.
2 pi r h plus 2 pi r squared. Good. Go ahead and calculate this for me, please.
Okay. Um, 66 pi.
Okay, so 66 pi, 2 pi is your radius 3,
Yes.
right? Times height 8 plus 2 times pi 3 squared. So as long as you got all those right, which I'm sure you did, 18 pi, 66 pi, excellent. Okay, all right. Any fault to that or any sort of thoughts?
No, I think I just have to like memorize like which equation goes with which total area.
Exactly. Yeah. Right. Okay. So let's take a look here at number 12. We're in the B's now. These are going to be impossible. No, C's is even more impossible. They do really get tough. I mean, after a while.
Yeah,
So,
for sure.
right. All right, find the total surface area of the solid shown, including the surface inside the hole. The way to do this problem is to recognize that there's a prism and then a cylinder that's cut out of it, right? It's a composition of three things. So the total surface area of the solid, what's interesting now is the surface area actually includes the part that's cut out, at least its surface. And this is much easier to see if you could like had something kind of drilled through it, or you were able to like access this little cylinder piece that's coming out. So the surface area is the prism, but you have to subtract out the face and the face. And then you also have to subtract out or add to it the surface area of the cylinder, the lateral area, not the surface area, the lateral area. So I don't know if that makes sense. It's kind of like a visual thing. You got to like imagine this piece like pushed out, and then there's like on the front face, there's a missing circle. Like it's 8 and 8, and then radius of 3, but it's like it's gone on that.
Okay, so we're just like the surface area will just be like the whole prism minus the faces of the pyramid.
And then added to it the lateral area of the cylinder.
Oh,
Yeah, that inside part.
yeah. Okay. Okay. So you subtract the faces of the pyramid, but you add the lateral area of, or you subtract the faces of the cylinder, but you add the lateral area.
Yeah. So like I would look at the prism part and say, okay, the prism's lateral area is 2 times the way the prisms work is it's 2 times the product of each of the dimensions. So 10 times 8 plus 8 times 8 plus 10 times 8. All right. But then you have to subtract out the circle pi r squared, but there's 2 of them.
Okay.
And then from here we have to add to it the lateral area of the cylinder, which is 2 pi r h, and the radius is 3, but the height is the 6th.
Okay. Okay.
So your answer will contain a number minus something with a pi in it plus something with a pi in it. You'll be able to combine those terms, or we can do it together here. So that's 10 times 8, 80, 64 plus 80 again. So 2 times that. Let's see what it was, 64. That's 448 minus 9 pi plus 60 pi. So
Okay.
448 plus 51 pi, like that.
It, okay, wait, for the 9 pi, where does that come
Oh,
from?
should be 18. Should
Okay,
be
okay. I
18.
was like,
Yeah, and I'm with you there. Like it's like, why is it working out? It doesn't look right. Now it does. Plus 42 pi, 448 plus 42 pi, like that.
okay, cool. Thank you.
Okay. What's next? What's
14.
next? 14. All right. 14. A, B, and C. Right. They never yeah. All right. So the thing that you'll do this again in calculus if you keep moving, progressing in math like you are. You'll see these rotations and what you're supposed to like they call it an axis of rotation. So you're like spinning this around. If you spin it all the way around, you end up getting a sphere. Can you see that half circle becomes a sphere?
Yes.
Okay, and so there's some other ones that are worth knowing. A triangle becomes a cone.
Okay. Yeah, yeah, yeah.
Could you visualize that?
Yes.
It's not a slight like if you don't see it right away, or it's just this is part of the course. You got to things like this. You can also have other things that are which is what you're going to see here, which is awful because like some of them it's like really visual. You can have rings, which we'll see, but let's look at A, and hopefully you've seen this before, heard of this shape before. A is kind of like the one I just did, but it's got its top cut off. So any idea what this becomes when you
Probably like a prism, but like maybe
so if this went all the way up, what would it be? We just talked about it.
a pyramid or like a cone.
Oh, a cone. Yeah, they're very different. You just be careful with that. So it's a cone with the top part cut
Oh,
off.
what's that called? It's
Called a frustrum.
a frustrum.
Yeah, I don't know why, but that's what it's called. And if you go to Google, there's formulas, but you know they didn't have Google back when the book was written in '94 or '93. So you have to do something else. Now it's asking for um, the total area. So we have to find the total area of this thing, which, ugh, I guess we do need the big triangle. I wasn't sure if we would, because I think what we have to do is look at this as there's like a lateral area of the cone that we've got like the big cone, take away the little cone to get this part lateral area. And
Yeah,
then
use
you've
like
got
use the 30, 60, 90 to like
right.
that.
Exactly. So what I see here, 60 degrees. So the short leg is the 6, and that makes this 12, and that makes the 6 root 3 like that. And so we want to find the area of the big cone, lateral area of the big cone pi RL, and subtract and I'll make that big R, and subtract the pi RL of the little cone, the one up here at the top. And that'll give us
Okay.
the I don't know, the frustrum lateral area.
Okay, so
This
it would be pi 6 times 12
yep,
would be 72.
minus, yep. Now this one we have to do the same thing with 3690. You have to find the slant height again, or yeah, which is 6. So it's pi 3 6.
So it would end up being 54 pi.
Okay. Now, that's only part of it, right? That's So that's the nice, I wouldn't say the nice part, but that takes care of the lateral area. So the total area is the lateral area. You just said it's 54 pi plus you have a top, which is a circle, pi r squared, plus the bottom, which is a circle, pi r squared. If you want to somehow use designators to indicate that um, you're differentiating between the large one and the big one, basically.
Okay,
Is that clear?
yes.
Okay, so this soon for you, this is now pi 3 squared plus pi 6 squared, 9 pi plus 36 pi, 45 pi plus 54 pi is 99 pi.
Okay,
All right, let me know when you're ready to move on to B.
yes, I'm ready.
Okay. All right, so this one's really tough to maybe visualize. Any idea what this looked like when you rotate it?
Uh, I want to say a cylinder, but I have like no idea.
It is a cylinder, but it's a cylinder that's being cut out.
Oh yeah, because of the space.
Yeah. So the challenge here, I think, is probably like, well, how do you convert what this is to this? Do you want to think of the total area as the large cylinder? Okay, that one, and then we're going to add to it. We're going to add to it the surface area of the little one, kind of like we did on that cutout, that cord. Think of it as a cord cutout from this one here.
Yeah.
So when you cut out there's this also counts towards the surface area, and then the top and the bottoms get subtracted by the cutout as well. So what you might want to do is draw the circles from the top and the bottom with some dimensions, like this radius is 2 and the big radius is 3. So it's all about like collecting the pieces, and I would start with like the big one, the lateral area of the big one. That's probably the easiest thing to start with. So the total area starts with the lateral area of the big one. That's pi big R. I'm sorry, 2 pi big R H. That's the lateral area plus the top and the bottom, pi R squared, but there's 2 of them. But then you're subtracting out the circle on the top and the bottom. Pi little r squared, but there's 2 of them.
Okay.
Please look at that again and make sure you really understand how I'm fusing those letters.
Okay, so this is like the total area of like that whole figure, which would start.
Yeah.
So it would
Sorry,
just
go ahead.
make, so the 2 pi r times the height is the lateral area of the big cylinder, right? And then plus the 2 bases. And then you're subtracting out the total area of the small cylinder inside,
No. We're subtracting out the little circle cutouts at the top and the bottom.
just the circle.
Just the circle cutouts.
There's not like a full cylinder inside.
We're gonna add it.
We're
Yeah.
gonna add it at the end.
I was gonna add that right now. I just want to make sure we got through like one of
Okay, okay, yes,
one
I
of
got
it.
it.
Yeah. And then now we need the lateral area of the smaller cylinder. And its lateral area is 2 pi R8. But we don't count the top and the bottom because it's
That's what we're taking
void.
out.
Yeah, exactly. Yeah.
Okay, I'll try and solve this and plug it in.
Okay.
Okay, I got 60 pi.
You want me to check that, or do you feel like you've got it?
Can you check it?
Sure. Big R is 3, little r is 2, H is 5. So the first one here is 30 pi
Mhm.
plus 18 pi minus 4 pi plus 20 pi.
Okay, yeah, that all
So
looks better.
64 pi. Is that what you said? I'm sorry.
I said 60. I don't know if I did that right.
18 minus 4 is the 14. I don't know, did you get the individual ones the same as me?
Let me see. Hold on. Let me do it again. Let me see if I get a different answer.
3 and 5. 9, 4. Oh, here we go. I made a mistake there. That's good. 8 pi plus 20 pi. Okay, yes, it is 60 pi.
Okay.
All right. Okay.
Is there another one or is it just
No,
eight?
yeah, of course there's one more. There's always one more.
Okay.
The fact of life. When you think you're done, there's another thing to do. All right, so
Mhm.
this one is the it's like the snow cone, kind of. It's like
Yeah, yeah.
there's a cone, but then this. It's really just three things. You gotta break it up. Okay, like what is that? Wow, that's drawn terribly. That's gonna be a hemisphere.
Okay.
Okay. The next one is going to be a cylinder.
And then the bottom will be a cone.
Exactly. And a cone. Okay, now in this case, the hemisphere, you do not have bottom. In the case of the cylinder, you don't have the top and the bottom. In the case of the cone, you don't have the top. So lateral area, lateral area, lateral area. Well, I'm sorry. Um, hemisphere is normally they usually say that's a good question. I wonder what they call it. It's the 4 pi r squared, but you only want half of it.
Okay. The lateral area of a cone is pi times the radius times the slant height, right?
Yes. And do you see that the radius is the same in all of these?
Yes.
What is your radius?
4.
How did you come up with 4?
Because with the hemisphere.
In the hemisphere,
Oh
everything
well,
is.
that would
Uh-oh.
Sorry, it like kicked me out. It like kicked me out of the meeting. I'm sorry.
No problem. I think it was just because you had the wrong radius. The Zoom said she's out of here.
Yeah,
Um,
would the radius be 8 then? I think I thought it would be 4 because I was like
yeah,
the whole thing.
exactly. Yeah, it in a hemisphere or sphere, the radius is the this distance from the center top, right, left, down. The all the radii are 8 in this problem.
Okay, let me redo this then. Okay, I got 424 pi.
I agree.
Okay,
Excellent.
that's something I'll have to look out for then.
These are really tough. One thing you could always do is try to explain this to someone else in the class, or so that's one way to see if you really understand it or not. There's a lot here, especially the ones where you got to take it out and then really still use it. They're kind of really tough. So,
Okay.
all right. Well, we have completed this. Do you want us to move ahead to something else in the book or other?
I don't know. I feel pretty good about what we did tonight. So
Okay.
I think I should be good.
All right, you are the customer, you dictate that. Happy to stop here. Just ask one more time. Is there anything else you'd like to work on tonight?
No, that should be it. Thank you.
Awesome. I didn't get to ask. Let me go and just stop recording here. I